Students, we have just discussed now the ionic radius, and we have discussed that the size of the cation is smaller with respect to that of the parent atom, and the size of the anion is larger with respect to the parent atom. Now it is related with the effective nuclear charge acting per electron, right? So if the effective nuclear charge per electron is more as that in case of cation, the electron cloud will be tightly held toward the nucleus. As a result, what will happen? The size of the cation is going to decrease. Whereas in case of the anion, right students? So there the effective nuclear charge per electron is less, and hence what happens there, that the electron cloud will be less tightly held toward the nucleus, and hence there will be the you can say the electron cloud less tightly held to the nucleus. As a result, the size is not going to shrink, right? It will remain, you can say it will remain as it is, but the parent atom, with respect to the parent atom, its size will be definitely more, as the electron clouds are not going to shrink. Now students, we are going to discuss about the isoelectronic species. Now what are the isoelectronic species? Now the isoelectronic species, students, are those species which have the same number of electrons. These are the species which have got the same number of electrons, right? Uh, but they will have different magnitude of nuclear charge. That is, their number of proton or the magnitude of the nuclear charge is going to change, right? But the number of electrons will remain same. Now we can define the isoelectronic ions. These are the ions, which have same number of electrons but varies in the magnitude of nuclear charge. So students, we can take an example of potassium K positive. You know that the atomic number of potassium is 19. So when it loses an electron, so the number of electron will be how much here? It will be 18. And the magnitude of the nuclear charge, we can say, is unit plus 1, right? Whereas in case of chloride ion Cl negative, here also the number of electron is going to be 17. But you can see that the magnitude of the nuclear charge is different here. Here it has got the -1, right? That means the number of the protons in the nucleus is going to be how much? It will be 18. Here it will be just uh, it will remain as it is. It will remain 17 here, the number of protons, right? Here only the number of electrons has increased. Sorry, so here it is going to be 18, right? Whereas in case of potassium ion, the number of electron is 18, but the number of the protons in the nucleus is going to be 19. So students, they are the isoelectronic species or isoelectronic ions. Now, when we are just observing the variation of the size of the of the isoelectronic ions across the period and down the group, we will find that when we move across the period from group 1 to group 17, right? So we will find that there will be decrease with decrease in the magnitude of the nuclear charge, right? We can say that just reverse it, that with increase with decrease in the magnitude of the nuclear charge, there will be the ionic radii of these ions are going to, we can say, it's going to decrease. Now, what does it mean? That if we take the example of the magnesium ion, right? This is the magnesium. Here it is magnesium ion. Then if we just put here, take an example of here. Let it be for the same, we are taking across the period, right? For the same for the same period, let it be now aluminum 3 positive, right? Students, you are supposed to just arrange this, right? So we are taking here magnesium ion, aluminum ion, Na plus ion. I'm just not arranging it is in a irregular sequence, not a regular sequence. And we have here, let it be N3 negative and it be O2 negative. So students, you have to arrange these ions in the, we can say, in the increasing order of their size. So just students try to do it. So students, here what you will find that the size of the isoelectronic ions decreases with increase in the magnitude of the nuclear charge, right? So in other words, we can say that the within the series of isoelectronic ions, as the nuclear charge increases, the attractive force between the electrons and the nucleus also increases. So students, what will happen? This result in the decrease of the ionic radius. So here if we just see magnesium ion, sodium ion, right? And we have got a oxide ion and the nitride ion. Among these, the size of the ion of the nitride ion is going to be more. So if we just arrange these series, so what we will get here, that here let it be aluminum ion, then it is magnesium, then it is sodium, then it is oxide ion, and then it is nitride ion, right? So here you can see that the magnitude of the nuclear charge is maximum in case of the aluminum ion. So what will happen? Here the effective nuclear charge of this ion is more. So what will happen here, students? So there will be more pulling of the electrons in. So what will happen? There will be the decrease in the size of this aluminum ion. So as we move ahead, right, coming to magnesium ion, then to the sodium ion, right? Then to the oxide ion and the nitride ion. As the nuclear charge or the magnitude of the nuclear charge is decreasing, what is happening, students, here? Since effective nuclear charge magnitude is decreasing, there is increase in the size of these ions, right? So the isoelectronic species, again, these are species which have got the same number of electrons but they differ in the magnitude of the nuclear charge, right students? And if we just want to compare the size of the isoelectronic species, right, we are just going to see the charges on it, right? As the nuclear charge will increase, the attractive force between the electron and the nucleus will also increase. So this will result in the decrease of the ionic radius. In other words, we can say that the size of the isoelectronic ions decreases with increase in the magnitude of the nuclear charge. right? So magnesium ion here, so here in this case we have aluminum ion which has got highest nuclear charge, right? So that is how much? It is 13 units here of the nuclear charge will be there, and the nitride ion has got the smallest nuclear charge, that is of 7 units. So in this case the nitride ion, that is N3 negative, will have largest size, right? So students, you will go through it and try to understand the concept which is being applied here, right? And from here you can get the conceptual based questions in your exams.